All right, guys, of relevance to the quiz, quiz not this week. This week is on geometrical optics. You have, we'd like to see, folks, if we can, it's relevant to the final exam, actually, okay? Might not be able to quiz you on this because the quiz this week, we are at, today is March 23rd. We have a quiz on March 25th. And that's on geometrical optics. That's the two lenses that I told you about. We have another quiz next week, and that'll be March 30, and then we don't have a quiz after that. So this is of good relevance to the final exam. Tips for the final exam, I've told you what to expect. Geometrical optics, interference, and diffraction, and some modern physics, which I'll cover later today. Guys, I'm interested to see, let's say that we have slit, let's say that it tells you that you have a diffraction pattern. The problem tells you have a diffraction pattern such that, so you have a diffraction pattern such that the M equals 7 diffraction or interference maximum, M equals 7 interference maximum, coincides with the first diffraction minimum. Okay, so what is this asking you to do? It's saying that, let's say, slit width A is 4 micrometers, okay? Then what is D? So that's your question, okay? Pause the video now and see if you can find that out on your own. Okay? We're not given lambda, we're not given anything, we're just given, this, so please pause and do that. All right, let's take a look at this. It is saying that at the position of the first diffraction minimum, I happen to find the M equals 7 interference maximum. Now, it could be the case that, guys, I'll tell you this now. If this is M equals 7 here, right, you can tell that what is M equal to over there. Can you tell? If this is theta 1 and sine theta 1 is given by lambda over A corresponds to M equals 7, sine theta 1 diffraction minimum corresponds to the M equals 7 interference maximum. What does theta 2 correspond to? What M is there? If this is M equals 7, you can tell because the sine theta 2, right? Sine theta 2 diffraction is 2 lambda over A. You can easily tell that'll be the M equals 14. Because we're going to play with this, play this game now. So if this is M equals 7, first thing I'd like to address is how many interference fringes do I see in this? Let's talk about this, okay? I'll see what? I'll see this is M equals 7. This is the 6. So let's say the M equals 7 maximum coincides there, right? It looks like the minimum is there too, but let's say that actually, let's say that in this problem, the M equals 7, looks like this, that's like that, and then actually the maximum is here. The maximum is squashed by this. It was kind of not clear. So let's say that looked like the M equals 7 minimum before, but that's fine. Let's say that the M equals 7 maximum, as it says, interference coincides. So what do we have? If this is M equals 7 maximum, then the M equals 14 maximum. Okay? So if A equals to 4, what is D? Well, again, I'll let you think about why this will be the M equals to 14. Okay? And if this is 7 and this is 14, how many do I see in between? Well, you have to use counting now, okay? 7, what is in between? I don't see 7. 7, you cannot see that, okay? You see 8, you see 9, you see 10, you see 11, you see 12, you see 13, and you don't see 14, okay? On this side, you don't see 7 either on this side. So how many fringes are there in the central peak? We have M equals 0, 1, 2, 3, M equals 0, 1, 2, 3, 4, 5, 6, right? So 0 to 6, that's 7. 7 on one side. Okay, I don't see the M equals 7. The last one I see is the M equals 6, and that's kind of small right here, right? So that's this one I see. This one I see. I'm gonna, color them for you, right? This one you see, and this one you see, and so on and so forth. You see the maxima, okay? So I'm hoping I got it right. Okay, so you see this guy, you see that guy, 1, 2, 3, 4, 5, you know. So, okay, was this a 7? 1, 2, 3, 4, 5, 6, 7, that's correct, yes. 1, yeah. So I see, look at this, I see 0, I see 0, 1, 2, 3, 4, 5, 6 on one side, but I've counted the 0 already, right? So I have 7 on one side, and I have 6 on the other side. I see a total of 13 bright fringes in here. Okay? And if this is indeed m equals 14, I see 7, I don't see 7, I see 8, 9, 10, 11, 12, 13. You see what I'm doing? I'm using counting on my fingers, back to grade 1. We have to do that, otherwise you're going to get thrown off, right? We say, for example, the central peak is double the size of that guy. So if this has 13, does this mean this has 6.5? No. In this case, this has what? The 8, the 9, the 10, the 11, the 12, and the 13. It has exactly 6 in it. So this is 13, this has 13, this has 6 in it. But widthwise, it is, you know, half the width of the central peak. Okay? So let's talk about how we find A versus D, okay? So what do we have here? We have sine theta diffraction 1 is equal to lambda over A, all right? And at that position, I am saying that I find the m equals 7 maximum. So that angle is also equal to sine theta 7 interference 7, and that's equal to 7 lambda over d. So from here, guys, I get that lambda over a equals 7 lambda over d, and I get that d is equal to 7a. Therefore d is equal to, what is 7 times 4? 28 micrometers. Okay. All right, so continuing with this, if this is m equals 7, how do I guarantee this is m equals 14? You can tell from here, guys. So sine theta, what angle does that correspond to for interference maxima? That's sine theta m interference, that's equal to m lambda over d, right? So what is this telling you basically is that these angles are equal now. Okay, what do I find? What m do I find here? That gives you the m lambda over d. For the second interference, for the second diffraction minimum is equal to 2 lambda over a, and that tells me that m is equal to what? 2d over a. That means that m is 2d over a, right? And what is d over a? D over a is, we get from that, d over a is 7, right? This means that d over a is 7, and this is 2d over a, so that is equal to 14, okay? It becomes really interesting, and this is what you need to think about, guys. When I have a diffraction minimum, an interference minimum coinciding with a diffraction minimum here, what do I expect to see there? I'll let you think about that. If this is, for example, m equals, if this is a minimum, this will be m equals 7.5 or 6.5, okay? 6.5 for interference maxima means I'm at a minimum. It could be 0.3 as well, really interesting. What happens if it's 1.5? If it's 6.5, what if I have a diffraction, if I have at the first diffraction minimum, if I have an interference minimum, what am I going to get there? Am I going to get another interference minimum? If this is 6.5, what is double 6.5? 6.5 means I've missed, so if I'm looking at maxima, I mixed maxima, and I got 6.5 means I've mixed the maximum. 6.5 puts me at the minimum exactly. If this is 6.5, what is that? 13. So is that maximum or minimum when I'm looking at maximum? So you'll have minimum, maximum for interference coinciding with the diffraction minimum. This is the end of the diffraction chapter. Okay, do the notes and do the examples. We're going to pause and continue with the modern physics part.